first topic we're going to cover in Calculus 2 is antiderivatives. So before we do that, let's remember what derivatives are. So remember, derivatives from Calculus 1 should be, if we have a function, it's the function that tells us all the slopes of that function. So, and the way we find these is, and we usually denote it something like f prime of x or y prime or dy dx. So if we just use this notation, f prime of x, remember how we do this is 2x plus 5. And let's just do a couple more examples just to remind ourselves how these go, just some basic ones, and use some different notation. So another thing we could take the derivative of is y equals sine of x. When we take the derivative, we could, here's some other notation, dy over dx also means the derivative of y with respect to x. And remember, the derivative of sine is cosine. And maybe one more just to have a few examples. So also, if we label a function like y equals 3 e to the 3x, we could use just y prime as the notation. And so in this case, we have to use the chain rule. So remember how that goes. E to anything, that sort of derivative is just e to that thing again. But since we have 3x up in the exponent, we have to take the derivative of that and multiply it. And the derivative of 3x is 3. And so here's 3 different derivatives. And so let's talk about what an antiderivative is. So our antiderivative sort of reverses what the derivative does. So let's see how we can talk about this. So the question we're answering is this: if I am given a function, we'll call it little f, can I construct a function, a new function, we'll say, a new function, capital F, so that the derivative of capital F is little f. In other words, so that f prime of x is equal to f of x. Okay, so this is the question we're going to try to answer. And let's start with some sort of basic examples. So first example, so let's find an antiderivative of, and we'll just call it little f. F of x equals 3x squared. Okay, so can we find the antiderivative of this? So remember, we want to find a function capital F of x so that when I take the derivative, I get little f, right? So what would that look like? So what does capital F of x look like? So remember, I mean, you probably, memorized what function has this derivative. So what are we saying here? If I take the derivative of x cubed, what am I doing? I pull the exponent down up front as a coefficient, and then I get 3x, and then I take 1 away from the exponent, so that's 3x squared. So if I'm asking what is an antiderivative of 3x squared, well, one answer could be x cubed, right? And if we want to check this, all we're doing is taking the derivative of this, which is 3x squared. So this works. So an antiderivative of 3x squared, one answer is x cubed. And so something we should address here is, so are there any other functions that do this. In other words, are there any other functions whose derivative is 3x squared? And the answer is yes. And this all comes down to the fact that if I take the derivative of a constant, add it on, it just goes to 0 and sort of disappears, right? So I could have chosen f of x equals x cubed plus 1, or f of x equals x cubed minus 500, or f of x equals x cubed plus 1/3, right? And on and on. I can add anything onto this, and notice if I take the derivatives of these, they all have the same derivative, 3x squared, because the derivative of the constant is 0. Okay. So we want to sort of encapsulate this issue. You know, each function won't just have one antiderivative. It could have, you know, infinitely many, and every function will. Okay. So how to talk about this? So to talk about this, we define something called the indefinite integral. So the indefinite integral is of f of x is the family of functions whose derivative is f of x. So another way we can think about this is it's all possible antiderivatives. Okay. And we have notation for this. So the indefinite integral, it looks like this. We have the function, this s is going to stand, really it's capital S standing for sum, but we don't know why that's true yet, but we will by the end of this course. And this is the, you know, differential x, differential of x, and it acts as sort of the right bookend of that and the left bookend. And then we would say that it's capital F of x, and usually we pick the simplest possible version plus c. And so any antiderivative plus any unknown constant. So c can be any real number. So let's see how the example works in this notation then. So if I'm taking the integral of, or the indefinite integral of 3x squared, if that's the question, the answer is I'm going to choose the simplest possible antiderivative, x cubed, with nothing added on, and then I'm going to put a plus c. Okay, so this kind of function with the plus c is what we're calling the indefinite integral. And if we choose anything to be c, these are all antiderivatives. Okay, so, and we'll talk about these as we go. So next video will be some examples.